Welcome guys, quick recap on what we have done so far. So we had two squares or cubes, so we were trying to mesh them, and we dumped the study. Why we dumped the study? Because we wanted to use that dump study in order to start our meshing automation process by changing few bits and pieces in the dump study. Yeah, if you like. Right, so now it's time to study the dump study file because we have already learned about classes and objects, and we want to put that learning into use. Why did we have to learn about classes and objects? So let's begin. And I've opened the dump study file without the visuals. Okay, so this is the simple dump study file, and normally when you're trying to automate the meshing, you wouldn't really require to put the BTK on or the visuals on, but that's okay, we'll look into it later on. But as of now, let's just learn how to read it. Once you open it, so you're gonna see import sys module. Sys module, it allows you to have access to the variables used by interpreter. We'll come back to it, no problem. And next one is Salome, obviously because you need you're working in the Salome, so you need that package. And then the next line which you read is Salome init. Now this is initialization of your Salome package, right? And then you have import Salome.notebook. I'm not sure if you can see it. Yeah. So you see when you're dumping this study, so sometimes you might use these ones, other times you might not use these ones, but they are initialized. So in case if you choose to use them, because these are there. Anyway, moving on to the, so don't worry about the notebook at the moment. So you have your sys.path.insert. Now this puts your scripting file, whatever file you're working with, so it puts that folder inside the path. Okay, so when even if you're running from the command line, so this folder will be looked into, right, while looking for the Python file. So that's basically what you're trying to do. So when you run a Python script from the command line, so there is a path contains all those folders where the interpreter is going to be looking for the Python file. But in case if you choose to give some extra path, so that's where your sys.path.insert is used. Okay, now moving on to the next one. Now we come to the geometry component. Okay, now you say import geom, right, because you're into the Salome geometry module. So from salome.geom import geom builder. So you're about to build your geometry, right? And then you need your math and import Salomids and import globals. Don't worry about the globals, I put these ones. Let's just take these ones away for the moment. Okay, so you're not gonna be seeing globals anyway. So import Salomids, don't worry about this one as well. So we're just gonna be looking into stuff which we will be using, right, which will come handy. So now when you say import geom, so you are saying geompy is equal to geombuilder.new. GeomPy is an object. How do you know that? Well, we said Geom Builder. So imagine Geom Builder is your package, and then there is a class called new in it. From that class, you are making an object. Now, why do you need object from that class? So once you have created the object, then that will allow you to have access to all the attributes and all the methods of the geombuilder.new class. Okay, so when you have your jompy object, so with that object you're gonna put method on it. That method is called make vertex, and then you're gonna be having your vertex 0 comma 0 comma 0. So these are the values which you will be providing to make your vertex. That result which you'll be getting, you'll be holding that in your O object. So you make your first x-axis, so that's gonna be held into O. Now then we created our square one or cube one, whatever you want to call it. Jompy.make box, so that's the method which jompy object used in order to create your square. And now the arguments were the lengths of the cube, right, your length, breadth and height. So those are the arguments given to the method. So that's how you created your square one. We created our square one, and we also created the second box and we named it square 2. So that stuff is happening here. Jompy.make box dxdydz. So these are the arguments which were given. So remember that was imposing onto the first one, the box. So which is why we were having same arguments. right? And then we translated that box by a value of 300 units, remember? So that's exactly what I'm doing. So how was that done? Basically that was done by saying jompy.make translation of what? You see over here we were having 3 arguments and now we are having 4 arguments. Why 4 arguments? Because we need to give first argument as that entity which has to be translated. So we wanted to translate the box 2, which is why we gave box 2, and then along the x direction or y direction or z direction, this is, we wanted to move it in the x direction by unit distance of 300 units. And afterwards we made another box, yet again another box, and we gave the values as arguments as 1700, 800 and 800. This was the bounding box which is going to be containing your 2 squares inside or 2 cubes inside, right? And then we translated that in order to, and then we adjusted the box 1, right? And we didn't name it anything because we knew that we were gonna apply the cut method to it. So the jompy, you see the jompy object which you have, that has access to all these different attributes. So it can make vertex, it can make a vector, right? So you can say these are the x's which you were making, and then it can make box, you name it. You can see there are so many methods that once you've created your object, and then you can have access to all these methods inside that class. So which is the class is geobuilder.new. So when you apply the cut, then you have to tell which is your main tool or main body. So translation 1 was your main body and you wanted to take away square 1 and square 2 out of it, yeah, and we say true. So that's when cutting starts happening. So now you have square 1 1 is equal to jompy.create group. So you wanted to create groups as well because we wanted to have full control over our squares or cubes, right? And then you are giving the IDs. So union IDs means these were the face numbers which you interacted. So remember the square or the cube, it has 6 faces, so which is why you're having 6 values here. So those 6 values are contained within the list. So be a bit accustomed to list and tuples because we'll be using them over and over again. But as of now, don't worry. So we union ID, so these were the faces which were used, and then you created another group, right? Out of the cut one was your main body, and then you decided that you're going to be making group of faces. And what were the faces? These are the 6 faces, right? So you called it square 2. Okay, no problem. Now you see, so these were the commands which you were executing while you were on the screen. Okay? These commands were recorded by using add to study method, right? So you see every object which you created, this is followed by a string value. So add to study, this is the string value which is being recorded. So these are all strings which you see in green, correct? So you created your origin first, and then you created your axis, then you created your boxes, then you translated, you performed the cut operation and all that kind of stuff. So that's basically what your jompy object is capable of doing. Now jompy object obviously had access to many methods inside the jombuilder.new class, and this is one of the method. Which method? This add to study, right? So that's basically about the geometry, how you read the geometry aspect of the dump study.